I'm a little tired of Burr. What happened to that groundhog? You said no more no.
You don't know nothing.
Okay, 8.4 is all story problems, and 8.5 is also story problems. So what I've given you is a sampling of the stuff that pops up. Okay, so these are all things that are going to end up showing up in your either your practice or in your certify. Let's stick one under there. And so let's see if we can go through and set some of this stuff up so we can figure out what we do have to do with it. Now in this section, the story problems are all dealing with travel or distance equals rate times time. Hawks has been a big pusher with, or a big area that has all kinds of distance equals rate times time. We did some stuff in basic algebra with rate times time, and now it's come back again. But the nice thing about the story problems that you have in these two sections is that you can deal with 2 letters as opposed to 1 letter. See? Oh, you're going to pack it up, okay? Okay, good. I thought I caught everybody. Thank you. Okay. But you can do it 2 variables. So always keep that in your mind when you're reading these, that somehow I need to have an X and a Y, or somehow I need to have letters that represent the 2 pieces of things that I have in here. And you don't always use X's and Y's, but we can go through and figure out what we got to do. So then once I get the equation from my story problem, then I can use graphing, which I most likely will not use, or substitution, or the addition that we talked about in 8.2 and 8.3. So let's go through and figure out what we got here. 2 trains leave St. Louis at the same time. That's a big clue in here. Brooke, you had that one that we just got done doing that had same time in there. And so the same time that we have means something to us. That means they're leaving exactly at the exact same time. One train travels east and the other travels west. So if I looked at my 2 trains, they're leaving the stations. One's going this way and one's going that way. Okay, sometimes drawing helps you out too. The speed of the eastbound train is 8 miles per hour greater than the speed of the westbound train. So what in the world does that mean?
The one train is X, the other train is X.
Okay, we're going to make the westbound train, we just got to put train in here first. Because it does end up changing things. So this is west and this is east. Because this piece is giving me a piece of information too. That means it goes greater than. What does that mean? That means it's going to go faster, right? So which one's going faster? The eastbound train. So this train will make it train X and we'll make this train Y. And so what does that mean? Well, it means the rate of speed that this train is going at is going to go at Y plus 8. Everybody okay with that? How we got Y plus 8 in there? And this train is just simply going at Y speed. And so if I put my X in front of here, X equals Y plus 8 for the speed of my train. You all right or not all right? After 7 hours, they are 812 miles apart. Find the rate of each train. Assume the train travels in a single straight line in the direction and the opposite directions. So what are my 2 pieces of information? Well, one piece is X equals Y plus 8 because that will be the speed of my X train. And is that what we're looking for? Yep, find the rate that each train is traveling at. So what parts do I know here? So if it's after 7 hours, how long has each train been on the track?
7 hours.
Yeah. Each one's been on the track for 7 hours. Okay. So if Y's rate is Y, so 7 times Y plus this speed, which is x, which is going to be 7 times x, is going to end up equaling my distance, which is 812. This one's kind of one of the more complicated ones in here too, because you're trying to say, okay, wait a minute, if I put these speed pieces in here, I should end up coming up with what my answer is, in which that's basically what you do, because if this is one equation and that's the second equation, what do I have to do? Well, in my bag of tricks, I'm going to pull out and use substitution, and I'm going to put 8 or y plus 8 in place of x. 7y plus 7 times y plus 8 is going to equal 812. And if I solve that, what am I going to end up with? Well, I get 7y plus 7y. 7 times 8 is 56 equals 812. 7y plus 7y is 14y equals 812. Subtract 56. Trust you guys out there with your calculators. Give me what that would equal. 812 minus 56.
756.
One more time.
756.
756. Divide that by 14, and I find that train Y, the westbound train, is traveling at what's 54 miles per hour. And then I need to go back. That's only one of my answers, right? And so I need the second answer. So what's the second answer going to be? Well, take 54, put it back in where Y is at, and solve for x. So 54 plus 8 gives me x is equal to 62 miles per hour. Now in Hawks it will say, what is the speed of each train? So they will put a little box down there and say the eastbound train, so be careful, make sure you put them in the right box, because if you put these in the wrong location on your Hawks, it'll say it's wrong. So make sure you get them in the right spot, okay, as you do that. So if by chance you take your test and you put them in the wrong spot, and I go back and check it, and you got the right answers, but you put them in the wrong spot, you'll probably get some extra points for that, okay? But just be careful and make sure you get them in the right spot so you get all of your credit instead of only parts of it. All right or not all right? Okay, so if we recap it, same time meant something to me, because if they tell me my number of hours, that's going to tell me that piece of it. This section here is telling me again what my speed happens to be with that, and so I have to make sure I pick out my eastbound train and make sure I say it's X and the other is 8 plus the westbound train. No longer is it all one letter. Okay, that's I think the hardest part with these, is sometimes you get the idea that if I can keep that same letter, I'll be okay, but it's using 2 letters with it. So let's take a look at the next one. Next one says, a small plane flew 370 miles in 24 hours with the wind. Ooh, okay, so with the wind, we got the wind. What's the wind doing for us? Pushing, helping you out. Okay, it's going to get you there faster. Then on the return trip against the wind, it traveled only 290 miles in 25 hours. What were the wind velocity and the speed of the plane? Do I know either of these?
No.
So if I don't know them, what does that mean? It says no, the speed of the plane means how fast the plane would be flying without wind. So that's kind of our clue thing. So these end up being our 2 variables, okay? So if wind velocity, we're going to label wind W, okay? Now in Hawks it may not do that, but I think for you guys it's a little easier to have some understanding of what you got going here. Speed of the plane, we're going to label that S. So make sure somewhere when you're doing these that you figure out and label what your variables are. Because if you label those variables, then when you get back to plug in your answer, you'll have a better chance of knowing what you got there. Okay? So let's go through and piece our stuff together. Well, it is a distance equals rate times time situation. So if I chart this, distance, time, and rate, I can plug in my pieces of information, can I? Okay, so the plane leaving and coming back. So what do I know about the rates of speed with this plane that's leaving and coming back? Well, if it's leaving, the wind is pushing with it, so what does that do to my rate? It takes my speed of my plane plus the wind to make it move, correct? Are you all right with that part? Yes? Okay. And what does it do when I'm coming back? It takes the speed of the plane and slows it down based on the wind. Okay. So far so good? How long did it take them? What's my time?
25 hours.
25 hours here and 25 hours there. What was my distance? So if I traveled with the wind, how far did I go? And if I traveled back home, I only traveled 290 miles. Okay. Now, is this plane moving very fast? I don't think I'd want to be flying in this plane, right?
Pretty slow.
Pretty pokey slow. Okay. But anyway, it's what we're given, so we got to make this thing work. So, where are my two equations? This is equation 1, and this is equation 2. So equation 1 is this piece up here. So I've got my rate times my time. So S plus W times my time is going to equal 375. And then the bottom one is my rate minus my wind is going to equal 290. We okay? Okay. So if I want to solve these, just multiply. 25 times S is 25S plus 25W is equal to 375. And 25S plus, or minus, 25W is equal to 290. Now, what tool do you want to use? So now we got a system of equations that we've come up with. What does it make you think of? Because again, we can use graphing, but I don't think you want to graph this because you have to get it solved for one of the letters and plug it in and figure out where the two cross, and that would be too much of a problem. I can use substitution, but would I like substitution? Substitution means I need to get one of these letters alone, and boy, I got a lot of stuff I got to do to it, right? Because I'd have to move my 25W over, and then I'd have to divide by 25, and I get fractions, and not a good sight. So, but if I look at this, what happens right here?
Cancel.
I can cancel those babies out. If I add them together, they're opposite of each other, so hey, that's what I want to use. So when I went through that and told you all these things, that's what I got going on in my head. I'm looking at it saying, what in the world do I got to do? Okay? I will probably more than likely not pick graphing, but so I get 50S. I get, those guys are gone, 375 minus 290. What's that going to give me? What was it again? 665?
No, just 65.
No. What was it?
Oh, yeah.
I got to add them together, guys, so I'm not going to subtract it. What do I get?
665 and add them.
655. No, I got to add them. Notice.
Minus, that's
Did
why
I?
you were going.
Oh, that's why. Oh, I'm sorry. I'll take that back. Erase.
665.
You got to add them. 665.
Yeah.
There we go. Divide that by 50. And what is the speed of my airplane? How fast are we going? One more time. 13.3. That doesn't sound good.
That's not very good.
No.
Real small plane.
I don't want to.
I wouldn't even want to be off the ground with that plane.
I don't think you could.
Okay.
But that's an answer.
How fast is the wind? Am I done? No, I gotta go back and find out what the wind's doing to this thing. And so if I plug that back in here, I'm going to have 25 times 13.3 plus 25W is equal to 375. So 25 times 13.3. What was it? 332.5 plus 25w equals 375 minus 332. So take that away from 375, and what do I get?
42.5.
And then if I divide 32.5 by 25,
42.5. What's this about?
what did you say wrong?
I got 42.
Oh, okay, I wrote it wrong. So take 42.5 and divide it by 25. So my wind is 1.7 miles per hour. Oh, okay. Not a good plane to be on. I'm staying home. I'm not hopping on that plane. It wouldn't even get off the ground. Okay, what was that?
I'd rather just drive.
To take you 25 hours? You bet. Yeah. To travel that far. So, yeah, that's kind of that's what happens sometimes when generators are used to generate problems. They don't generate some realistic type stuff. Okay. Next one down here. I need a sheet of paper with that one. It says a flock of geese flying with the wind. So this is kind of like the last one. Travel 440 miles trip in 8 hours. Hey, I'll go with the geese. I'll travel with the geese. You bet. And then it says on the return trip against the wind, the flock travels only 150 miles in 6 hours. So let's assume S is the speed of the flock in the air and W the wind speed. So S is the flock, W is the wind. So if we set this thing up, we can chart it just like we did the last one. And I think once you got one of these, we probably won't finish solving this one. We'll just set it up so you have an idea of what's going on. So what happens here? 440 miles. So if we've got distance, rate, and time, we know the distance is 440. We know the time the flock flew was 8 hours, but they were flying with the wind, so that means I have S plus W. We okay with that part? And this is coming back. So if they come back, they're flying against the wind. It took them 6 hours, and it took them, they ended up only traveling 150 miles. Strong wind that day. Okay? Make sense? Okay. So if I set this one up, I'm going to have 8 times S plus W equals 440. And then I'm going to have 6 times S minus W equals 150. And we're going to leave it there. Is that okay? You guys can finish that one, you think? Yes? No? Okay. So, so yeah, you could end up finishing that one, and so if you work the whole thing out, you'd get 8S and 8W and equals 440, and then 6S minus 6W. Get a little more work in here to do because your W's don't match, so you got to do some multiplication, all right, to get that number to go away. But that's that type. Okay? Yes or no? Yeah. Okay. Good deal. Let's take a look at some other ones that happen to pop up in here as well. There are number ones. Everybody likes it if they get a whole bunch of number ones in their certifies usually, because they're the ones you kind of go through and know what you got to do with. It says the sum of two numbers is 65. So what does that mean? Yeah, so it means just simply x plus y equals 65. Their difference is 11, so that means x minus y equals 11, and so guess what? I've got my two equations. So what method do you want to use? Substitution? Eliminate or addition? Which do you think you want to do? Addition, because? Yeah, these y's just disappear. So x plus x is 2x. Y's are gone. 65 plus 11? What does that give me? Divide by 2. So I find one number is 38. So what's my other number? So 38 plus y equals 55. Subtract 38. And I find y is equal to, what's y going to be?
It's 65.
What, 65?
65, it's 50, it's not 55.
Oh, 65, thank you. Yep. That helps. 38 from 65. What does that leave me with? 27. Does it work? 38 minus 27 does end up equaling 11, so I'm pretty much safe. And we know 27 plus 38 is going to give me 65 because I did my math correct there. So, okay, good deal. All right. Ready for the next one? Okay. Jason is 11 years older than his sister Kate. In 6 years, he will be twice as old as Kate. How old is each at the present time? Do I have enough stuff? So we're going to say Jason. What letter do you want to give Jason? J. Okay. And Kate is K. So we got Kate as being K. So what does this tell me? It says Jason is, what's is? Is, when we look at is in anything mathematical, is equals, yeah. So Jason equals 11 years older than his sister Kate. So what does that mean? Kate plus 11. Perfect. Okay, so that's one of my equations. In 6 years, what does 6 years do? What would it be?
6 years will be twice as old as Kate.
Okay, but who's going to be he in 6 years?
Jason.
So what does that mean?
6J.
Is it 6J or is it J plus 6? Which is it?
J plus 6.
J plus 6. Because in 6 years you're adding 6 years to J's time. Okay. What do we know about Kate? He'll be twice as old as Kate. So what do we know about Kate? 2 times K? But what's happening to Kate in 6 years? Is she just staying at the same age? So she's going to be, what was it?
2 times K plus 6.
Yeah. 2 times K plus 6. Because Kate's getting older too in 6 years. So there's my 2 equations that I happen to have. So what method do you want to use to solve it? Substitution? What makes you think substitution? You already have J. Yep, so substitution. So I'm going to put K plus 11 plus 6 is going to equal 2K plus 6. So K plus 11 plus 6 is 17. 2 times K is 2K. 2 times 6 is 12. Get my K's all together. Get my numbers all together. So we're going to find 17 take away 12 is 5, and K, 2K minus K is K. So Kate is 5 years old. How old is Jason? So back here, Jason equals 5 plus 11, so Jason is 16. Okay? Yes or no? We good? Okay. Yep. So that would be my 2 answers. Does it work? 16 plus 6 is 22. 5 plus 6 is 11 times 2 is 22 also. So we know we did our math correctly. All right? Yes? Okay. All right. The next one here is Darlene has some dimes and quarters. If she has 16 coins worth a total of $2.35, how many of each type of coin does she have? So you kind of get into some mixture variety of stuff that we happen to have here. So what do we get going here with Darlene? So we have dimes. So we're going to make those D, right? She has quarters. We're going to make those guys Q's. And what do we know about them?
She has 16.
She has 16. So what does that mean? She has 16 coins. Quite a combination. Yeah, she's got a few change there in her pocket.
Coins that are worth $2.35. $2.35.
Okay, so do we want to go down here to the worth? How do we get what the worth? So what's a dime worth?
10 cents.
10 cents. Okay, what's a quarter worth?
25 cents.
Yeah? And this all totals $2.35. But I only have one equation. What's D and what's a Q? A Q in there. What's D and Q meaning right here? So D plus Q equals 16 is what you're saying? Mm-hmm. Yeah. Because D plus Q equals 16. Because the D times the 10 cents is the number of dimes. The Q times the 25 cents is the number of quarters. So therefore, I end up with my two equations. We all right? So now, what do you start seeing? They look like some of the stuff we saw back in 8.2 and 8.3 because I've got decimals in here. All right? So if I got decimals, what that means then is that I can end up taking these guys and end up moving them all over. So I end up with 10 dimes, 10D plus 25Q is equal to 235. Okay? And it makes my math a little easier if I get rid of that. And then I have D plus Q equals 16. So then if I were to solve that thing, what method would you like to use? Substitution? Okay, because I can get D by itself pretty easy by minusing Q. So I have D is equal to 16 minus Q. Plug them in. Replace D, so 10 times 16 minus Q plus 25Q is equal to 235. 10 times 16 is 160. 10 times Q is 10Q plus 25Q equals 235. Put my Q's together and move my 160 over. Leaves me with 15Q is equal to 75. Is that right?
Yep.
Divide by 15. And so Q is equal to, what's Q going to be? 5. Okay. That's Q. So what's D? So D we solved up here, so 16 minus 5 is going to give me the number of dimes, and 16 minus 5 is 11 dimes. And sure enough, 11 plus 5 is 16, so I'm good there. And if I plugged it back in here and checked it with my calculator, I'd probably be good there also. Okay or not okay? Okay. Now, that's kind of the different varieties that are in that section. So let's take another look at what we got here, because I know I got some extra ones here, because I kind of pulled out a whole bunch of stuff here. So let's just kind of talk about some of these and figure out what we got to do here. Working your way through school, Diane works 2 part-time jobs for a total of 25 hours a week. Job A pays $4.50 per hour, and job B pays $6.30 per hour. How many hours did she work at each job the week she was paid $137.70? So, do I have 2 variables? What do you guys think? Yep, I got job A is going to be A. Job B is going to be B. And if that's what I happen to have for these two, what do I end up doing? Well, my first equation is based on 25 hours. Kind of like to change the coins we just did, because now I can just take A plus B is equal to 25. Okay there? And then the other piece is 450 times A plus 630 times B, and that's going to end up equaling what?
137.
Yeah. Yep, 137.70 would be what we get. Okay or not okay? Can you solve it from there? I think so. Let's go to Alice. Alice travels 3 times faster than Mike. Traveling in opposite directions, they are 192 miles apart after 4 hours. Find their rates. I gotta get an E in there. Of travel. What kind of problem is this one?
Distance rate.
Yeah, distance equals rate times time. So we need that little charted piece of information. Rate, time, distance. So we have, do we base it on Alice and Mike? Yep, Alice, Mike. What do we know about Alice and Mike?
Alice travels 3 times faster than Mike.
So Alice travels 3 times a Mike, right? So when we look at the rates going into the box, though, you're going to have Alice's rate and you're going to have Mike's rate, okay? Because these 2 rates are still theirs. It's just that we know a little bit more about Alice than we do about Mike. How long did they travel?
4 hours.
4 hours. Time's the same for both, isn't it?
Correct.
And what did they do?
Different directions.
So did each one travel 192 miles?
No, they were 192 miles apart.
Yeah.
Wow.
If you draw this thing out, remember, it's kind of like the train one we just did a little while ago. Mike is traveling this way and Alice is traveling this way. They're traveling in opposite directions. And this together equaled 192. So the total value of this was 192. So be careful with those because my distance is 192. So what's my equation? I got an equation out of this. I've got one equation, but I need another one. So what's the other one going to be? So we know that Alice traveled at A for 4 hours. Mike traveled at Mike's speed for 4 hours, but because these are together, they end up being a total. So 4A plus 4M is going to equal 192. We okay or not okay? Okay. Again, these should give you some help with doing your story problems when you get into your other part of what you're doing. Reggie made a business trip of 282 miles. He averaged 59 miles per hour for the first part of the trip and 47 miles per hour on the second. If the trip took 5.5 hours, how long did he travel at each rate? Little different twist here. Still a distance equals rate times time. But what do we know? 2 trips, right? 2 different times. First part and the second part. What did he travel at the first part's rate?
59 miles per hour.
59, okay. What did he travel for the second? 47 for the second. Okay. How long was he out? What was his times? For the first part of the trip, he traveled what length of time? Don't know, do we? Now, because we've got 2 variables, do we know how long he traveled on the second part? No. It can be y. Now, that's the part that makes this a little bit strange because they give us the total amount of 5.5 hours is what he traveled. And it was the total business trip. And the total business trip is 288.5. Okay? So what's my 2 equations going to look like? Well, one is based on time.
So x plus y equals 5.5, and then 59x
Mm-hmm.
plus 47y
Right. Equals.
5.
Mm-hmm. Yep. Okay. And that's my 2 equations. All right. A little tricky with that one because they kind of bounce around there with that one. Okay. One I want to do that's in here. I know I got some extra ones that are in your packet. But one that I want to take a look at is this furniture one. You can go to the furniture piece. Don't have a furniture?
No.
You got a length of a rectangle?
Yes.
Then you should have a furniture. Might be on the back page. That's where it ends? Go to your next packet. Maybe I cut it off. Did I cut it off?
Nope.
Don't have one. Well, we're still going to do it. You can watch up here, I guess. We'll stick it in the notes up here. But just know, somewhere in your notes, and I can't believe I chopped that one out of there, is you got a furniture type that pops up. And it says a furniture shop refinishes cabinets. Employees use one of two methods to refinish each cabinet. Method 1 takes 1 hour and the materials cost $6. Method 2 takes 2 hours and the materials cost $4. Next week, they plan to spend 92 hours in labor and $360 in materials for refinishing the cabinets. How many cabinets should they plan to refinish with each method? So we got method 1. We're going to label that X, I guess. And method 2. And we're going to label that one Y. So I've got two pieces of information here. I know that's going to take me 92 hours to do stuff, and it's going to cost me $360. So that's where the break is with these. So if I take method 1, and method 1 takes 1 hour to do, so if I have X times 1 plus, what's Y's? Y takes 2 hours, and that's going to be a total of 92 hours that I'm going to have with that. We okay with that part? Because I'm just breaking it apart. Then if I go back to my cost, $6 for method 1 plus $4 for method 2 is going to equal $360, and so that becomes my two equations that I have with that. Okay, and you will run across one of these in your homework stuff. So then you'd pick out a method to solve it. What method would you use? The addition one? Which letter you want to get rid of? X's or Y's? If you use that addition, you would use Y's, right? Because then what I would do is take this top equation and times it by a -2, which is going to make my Y's disappear. So let's might as well finish it. -2x plus or minus 4y is equal to a -184, I think. And then 6x plus 4y equals 360. And so these guys gives me 4x. 184 from 360. What's that leave me with? 6, 7, 176. Divide by 4. So I find x for the amount of hours that or amount of items I'm going to do at that point. So 4 goes into there 44 times. So 44 is method 1. How many do I do in method 2? So I'd have to plug 44 back in where x is at. Subtract 44. Get 2y, and 92 minus 44? 48. Divide by 2, and I find y is equal to 24. So I can do 24 items with method 2, and if I check it, plug it back in, 6 times 44 plus 4 times 24 should end up equaling $360 if I did it right. We okay? Yes? All right, good. So I think that should give you enough of the practice kinds of stuff that comes up in there with that one. All right? So I'm going to pause this. What was that? What was that?
Teachers are going to be kicking my butt.
Yep. It will be. All right, 8.5 is interest and mixture problems. So again, if you're having any difficulty with the last stuff we just got finished doing, remember in Hawks there is that little button you can push that sends your question directly to me, okay? And I'm on, so I will get back with you on any of your story problems. So if you run across a story problem that's giving you a problem, send it to me, okay? So that we'll have those. 8.5 is just dealing with interest and mixtures. They don't end up putting some extra stuff in there with what you have. Chart these. You can come up with your charted information and then pull your stuff out of those. So if we look at the very first one, and I think you should have that on your sheet, it says Irma has 2 investment accounts. One pays 5% interest and the other pays 9% interest. She has $900 more in the 9% account than she has in the 5% account. And the income from the 9% account exceeds, what does exceed mean? More than the interest from the 5% account by $200 each year. That's the tricky piece with this whole thing, is because we've got to come up with what that part of the equation happens to be. So that's one equation. Where's my other equation in there? Is there another equation in there?
The other pays 9%.
Well, yeah, but the other equation is right there, okay? She has 900 more in the 9% account than she has in the 5% account. Okay, so that's the second piece. So now we got to give these things some information. So the 5%, we're going to say that's which letter? What letter are we going to give that one? I'll just give a good old X. And the 9%, and if you do this on the side of your paper and label which ones you have, then you're going to get some more information out of those. So if I go to my first equation, she has 900 more in the 9% account than she has in the 5% account. What does that mean? If we go back to what we just got done doing, it means that the 9% account is Y. So how amount of money does she have in there? Well, she has X plus 900. You okay with that part? Because the 5% is exceeding by 900. So the amount that's in the X, or in the 5%, is going to have 900 more to give you what Y happens to be. So far, so good? Yes? No? Not seeing much out of you out there? Okay. So now we got to figure out what this thing means. And the income from the 9% account, so that's where your percentages come into play. And when you put your percents in, they need to be decimals. And so 9% of the Y account exceeds the interest of the 5%. And that's the tricky piece, because actually you need to subtract the 5% account from it to end up with the $200 difference in interest. Okay or not okay? Okay, so this exceeds, so watch that word when you get that one. So if we solve it, we're going to put this in place of Y, but before I do that, I want to multiply by 100 and get rid of my decimals. And so I'm going to have 9Y minus 5X is equal to 20,000. So it's going to change my 20,000 piece there at the end. Now if I substitute it in, I'm going to have 9 times X plus 900 minus 5X equals 20,000. So 9 times X is 9X. 9 times 900 is 8,100. Minus 5X equals 20,000. 9x and a negative 5x is 4x. Move my 8,100 over. We okay with that? I think I can do that, the same part, without losing some of you. And 20,000 minus 81 is what? 20,000 minus 8,100 is 0, 9, 19? No. 100 and, or 11,900. I think that's right. Divide by 4.
11,900.
Yep. Divide it by 4. Tell me what x happens to be. So x is going to equal, what was it again?
2,975.
One more time.
2,975.
Okay. And now I need to find out what y is. So in y's case, I'm going to add this 2,975 plus the 900. And what does y come out to be? Trust in you guys with your calculators out there.
Is that plus 2,975?
Yep, plus 900. Okay. And that's my two pieces that are invested. And if you check it, 0.09 times 3,875 minus 0.05 times the 2,975 should give you 200, if we did it right. We okay? What do you think? I know, story problems are just so exciting. Okay, another one down below here. A savings and loan company pays 7% interest on a long-term savings account, and a high-risk stock indicates that it should yield 12% interest. So we can do, we'll let L equal the long-term, and we can let H equal the high-risk. So just for letters. So we know we got two pieces in there. And the long-term's interest rate is 7%, and the high risk is 12%. So I gained that from the first sentence. It says, if James has $40,000 to invest and wants an annual income of $3,550 from his investment, how much should he put in the savings account and how much should he put in the stock? Okay. What do I know? 40,000 to invest. So what does that mean? So L plus H equals 40,000. Okay with that part? Some of our numbers get pretty big with these interest ones. And then he wants an annual income of this. That means the interest off of it. So 0.07 L plus 0.12 H is all going to equal $3,550. We okay? Okay. Then you can solve that one? Yes?
Yeah.
Okay. And again, check it when you get done with that. I would probably use substitution again because I can end up getting an L by itself pretty easily. Plug in that stuff in, get rid of my decimals, and come up with what I would work with that one. Okay or not okay? Okay. If you want these finished, just let me know, and I mean we can finish them so that you got an idea of what you got happening with that. Another interest. Genevieve has $18,000 to invest. She puts part of her money into an account that earns 3% interest and the remaining part into an account that yields 5.5% interest. If her total amount of income from the interest is this, $802.50, how much did she invest at each rate? And let's assume that X and Y are the amount she invested at 3% and 0.5 or 5.5% respectively. Like the last one. Any difference with this one? Okay. So if we set it up, we're going to have X plus Y equals 18,000 because that's what she's investing. And then we just simply put the interest in front of each of these and end up setting that equal to what she's earned. So they're pretty straightforward problems, and then you would solve it from that point. Okay? Yes? No?
Did you break down the 5.5 correctly?
Did I break this down right? Move it back 2 spaces. Yep, because I need to put it in decimal format to work with it. I can't leave it as what the percent happens to be. They all have to go back to decimals. So you want to be careful with that and make sure 3%. To do that, to turn it around, remember you're moving your decimal point back 2 positions, so you get 0.03 for your decimal. And when you have 5.5%, you're moving it still back 2 spaces, so you get 0.055. Okay? So you want to move it 2 spots back and get your decimal out of it. Okay? So be careful getting your decimals. Again, probably substitution. because I don't have to do a whole lot of math. Now you could use elimination or addition if you get these decimals out of the way, because it wouldn't be bad multiplying by, of course you have to multiply by 30 when you move this back, because you got to move it, multiply by 1,000, so you get some pretty big numbers that way. So that's that one. Jessica has money in 2 savings accounts. One rate is 8% and the other is 13%. She has $450 more in the 13% account, and the total interest is this amount. How much is invested in each savings account? Do I know what she's investing? Not a clue. So we have 2 accounts. So we have savings 1 and we have savings 2. So if I go through and I look at these, what stuff's going to have to go in there? So if I got savings 1, we're going to label that X, and savings 2 is Y, at the rate of 8% for one and 13% for the other. She has 450 more in the 13%. So what does that mean? So that means I have X more in the 13. So really it's Y is equal to X plus 450. You okay with that part? Yes or no? Be careful, because it says she has 450 more in the 13%, so that's Y, than she does in the X. So you've got to take X plus the 450 to get you that value. And then the rest of it is just simply your interest stuff. So 0.08X plus 0.13Y is equal to $237. All of these, they left your years as a single year. That seems washed out up there, doesn't it? I don't know. What was that? The lighting, I think, is our big problem with that, with those things. But okay. Mixture, and you can solve it from there, because all you gotta do is substitute that back in where X or where Y is at, and end up coming up with what your solution happens to be. Okay or not okay? Okay, mixtures. Mixtures, you are going to want to chart your mixtures. Now when you chart your mixtures, I'll draw this guy out here. You are not going to have, well, I guess I needed another line in there. We'll just put another box on the end here. You're going to have 3 sections to your mixtures. You're going to have a total at the bottom, and you're going to have mix 1 and mix 2. So be careful with that, because you've got values that you're going to put into place. So mix 1, mix 2, and the total. And what do we do with mixtures? Well, usually you end up mixing, of course, 2 things together. And within those mixtures, you usually have ounces, like this one has ounces. You can have pounds, you can have tons, you can have any kinds of different possibilities that you have in them. And a lot of times in mixtures, you have percents, or you have dollar amounts, especially if you're buying something and you're mixing 2 things together that have a dollar amount. And I think we've got one coming up here with those. But you have these different categories that you have. So usually it's something, in this case it's ounces, and it's percentages, and we end up putting the last box together of what they equal. So it's not only that you equal stuff going this way, but you equal stuff going the opposite way down as well, and what it comes out to be. So as I read this one, how many ounces each of a 10% salt solution and a 15% salt solution must be used to produce 50 fluid ounces of a 12% salt solution? You're kind of thinking, my word, I got all these percentages, and what in the world do they mean? So what do we know about mix 1? 10%. So I'm going to put my percent under my percent. Do I know how many ounces I have in it?
No.
No. So that's X. We okay with that part? Okay. What do I know about mix 2?
15%.
Is 15%. What do I know about its ounces? Nothing. And it's not related to this, so that's going to be Y. We okay? Okay. And what do I know about my total down here? Total is 50 fluid ounces, so that gives me an answer there. is equal to 12% solution. So I've got that piece. Okay so far? Putting all my boxes together? Okay. Now if I go across and go this way to get what it equals, x times 10% is 0.1x. Y times 15% is 0.15y. And 50 times 12% is going to be 50 times 0.12. We okay so far? Okay. Now, I've got my charted stuff. Now, out of this charted stuff, what in the world does all this stuff mean? Well, at one point, if I look at this thing, I have two separate equations. My first equation is right here because that happens to be my total values that I have, all right, of how many ounces I'm mixing together. My second equation, if I chart all this stuff, is right there. Now, because it's a mixture, what do I do with mixtures? I add stuff together. So this is an added in here. So this plus this equals this. This plus this equals 50, and so that becomes my piece that I have. But I need to find my spare sheet of paper here to write out my two equations. So my two equations happen to be x plus y equals 50, and the other equation is 0.1x plus 0.15y is equal to 50 times 0.12. Okay? Okay, so let's finish it. We'll solve this one. So, what do I want to use? Probably substitution. Get a letter by itself, so x is equal to 50 minus y. Clear out my decimals, so I'm going to multiply by tenths, hundredths, so I'm going to multiply by 100. So that's going to give me 10x plus 15y is equal to 50 times 12. And what's 50 times 12? 50 times 12? What was it? 600? 600?
Yeah.
Okay. Trusting you guys. Plug this guy in where y is at. So 10x plus 15 times 50 minus y is equal to 600. So I have 10x plus, whoops.
Yeah.
Oh, yes, thank you. Yeah, heading down the wrong path there. Yes, because this equals x, not y. So 10 times 50 minus y plus 15y equals 600. There, that's healthier. 50 times 10 is 500. 10 times a negative y is a negative 10y. And equals 600. Put my y's together, so I have 500 plus 5y equals 600. Subtract 500. And I get 5y is equal to, what was it? 100. Divide by 5, and I find y is 20. So I would need 20 ounces of mix 1. No, mix 2. You're in the right spot. 20 ounces of mix 2. And what do I need of mix 1? So 50 minus 20. So x is equal to 30. So I need 30 ounces of mix 1. Okay. Does it work? 30 plus 20 does equal 50. And 30 times 0.1 is 3. And 20 times 0.15 is 30. I don't know exactly what I'd get with that one. But we'd end up having our values. I think I'm supposed to come up with something like 6. So
20.015 or
0.1. 0.1 times 30 is 3.
And 20 times 0.015
Is 3 also. And 50 times 0.12 is 6. So 3 plus 3 is 6. So it worked. Okay. Yes or no? Okay. All right. Has it been very long?
No.
Okay. I must have hit it when, has it been very long?
No.
Okay. I must have hit it when I did put my pens over there. That's what I did. Yeah, get that mouse out of the way when I do those. Okay, so charts. Charts are best things. 3 lines though, don't forget. 1 for your mixes, 1 for, in this case, it's going to be percents. And I'm dealing with gallons. And then I'm going to get what it equals at the tail end. So mix 1, mix 2, and the total. So, what do I plug in? Well, 15% is 1. Do I know anything about the number of gallons for the 15%? Nope.
Could we have charged it in the same order we charted the last one?
It doesn't make a difference. I didn't want to stick them in the exact same because then you start thinking that they got to be all exactly the same.
Okay.
So 35% is, don't know what that one is for gallons either, but it's going to equal a 20%, and it's going to have 100 gallons complete. And so then, what do I get? Well, 15 times x is 0.15x. 35 times x is 0.3, or times y is 0.35y, and 0.2 times 100. So again, my 2 equations, one's here, the other one is where my equals is at. So the 2 equations are x plus y equals 100, and 0.15x plus 0.35y is equal to 0.2 times 100. Okay or not okay? Okay. Good deal, as long as we can get them in the right spots. Next one. Peter decides to mix grades of gasoline in his truck. Why do you want to do that? I have no idea. He puts in 13 gallons of regular and 7 gallons of premium for a total cost of $42.68. If premium gasoline is 24 cents more per gallon than regular, what was the price of each grade of gasoline? Can I chart this? Let's see what we get when we chart this. And is it going to be much of a help? Well, let's see. We have regular. We have premium, and equals the mix, or the total. What am I putting together in here? Putting together gallons, right? But what do I know about gallons? How many gallons? He puts 13 gallons of regular, so that means I have 13 of those. What does he put of premium?
7.
How much is the mix? How many gallons did he put in for the whole thing together? We can come up with that because 13 plus 7 is 20, but does that help me at all? Doesn't do a whole lot for me, does it? How many what's the price? The price of each gallon, oh, do I know the price of each gallon? X.
The premium is 24 cents more.
Then,
So you know that.
so that's our first equation. Y equals x plus 0.24. Okay. But do I know how much it all costs altogether? Yeah. $42.68. Okay. So 13 times x plus 7 times y is going to equal $42.68. Do I have to multiply 20 in there? Do I have to multiply that by 20? No, because the 20 is just my total number of gallons. So my second equation is right there. The first is kind of tricky because it's not coming out in here, okay? Because we don't know what that would be. So 13x plus 7y is equal to 42.68. So that one's kind of a tricky one, and you will run across those in your stuff as well. Again, substitution, plug it in for x, or plug it in for y. Yep. It equals y, so plug it in for y and solve it. Okay? What do you think? Do that one on your own? Okay. And then the very last one here. A metallurgist has one alloy containing 21% copper and another containing 35% copper. How much of each alloy must he use to make 44 pounds of a third alloy containing 33% copper? Like the last ones, right? But this one says round to 2 decimal places, so that kind of indicates to you what? Got some numbers that aren't so nice, okay? So if we chart it, 3 lines again whenever you chart. So we got alloy 1 and alloy 2 and total. And if we've got percents, what was it? 21 for the first one, 35 for the second one, and their total is going to be 33%. And what do we know we're measuring in pounds? So how many pounds of the first alloy? Don't know, so it must be good old X. You start to see a pattern with some of these equations. They start to get the exact same thing going all the time. Y is for alloy 2, because they don't know anything about it. And how much do we have? 44 pounds. Okay, so multiply across 0.21x, 0.35y, and 0.33 times 44. And so my 2 equations, one's there, the other one is at the end. And so x plus y equals 44. Get it up here in the screen a little bit more. 0.21x plus 0.35y is equal to 0.33 times 4 to be your values in there. Okay. Now, in solving it, again, if we solve for x, plug this in where x is at. Get rid of my decimals. They're all to the hundredth, so I can just get rid of those. So 21 times 44 minus y plus 35y is equal to 33 times 44. And if I finish it, you guys got to do some multiplying out there for me on your calculators, because I need to know 21 times 44. What's that going to equal? 21 times 44? One more time? Okay. Minus 21y plus 35y. And what's 33 times 44? Okay, 1,452 minus 924. 21 from 35 leaves me with 14. And what's the 924 from the 1,452? 528, you said? Divide by 14. If I divide by 14, what does y equal?
37.72. What does it say? How many decimals?
2 decimals, round to 2. 1, don't round it. Okay.
714, so.
Nope. 37.71, we all agree?
Correct.
Okay. Then I got to find out what x is. So x is going to equal 44 minus 37.71. So what does x equal? One more time. Okay. If I add these 2 together, I will get my 44 back. So I know I must have did something right. And if I put it back in here, it should come out to be the right answer. All right, good deal. Again, these all fit into your different types of patterns there. So hopefully it works. Again, if you got questions as you're doing these, that button in Hawks, you can send me a